Okay, trigonometric equations then. Last time we looked at some basic trigonometric equations, linear trigonometric equations, and they're solved in the same way as algebraic equations, but we need to state the range over which these solutions act, and that's what we were doing last time, so, or in the last video that we looked at. In addition to algebraic rules for solving equations, sometimes we need to use these trigonometric identities, and a bit more on that today. Okay? And as a reminder, these are the identities that are commonly used that you've got written down. Task 7 is to do with these sorts of trigonometric equations. Note, solve the following equations for angles between 0 and 360 degrees, so that's the range. The first one is a linear equation, so we've looked at examples of equations like that. What we need to do today is to look at quadratic equations, in other words, equations where we've got squared terms involved. So not x squared this time, but sine x squared. Remember the notation, the shorthand. If I want to write what's the sine of y all squared. Shorthand way of writing that is sine squared y. So it just means that. And if I want to put this into autograph, I can type in sine squared x, and it will recognize that as the sine of x all squared. Be careful, because the sine of y all squared, which is what this is short as for, does not mean the sine of y squared. Okay, that means what's the sine of whatever y is squared. I mean the sine of y all squared. And so we've got to be careful you don't make that error when you're thinking about things like this. Okay, I want to start off by looking at some ordinary linear quadratic equations that we've looked at before. X squared minus 6 equals 0. What values of x mean that x squared minus 6 is 0? Well, obviously here and here. So as a reminder, quadratic equations generally have two solutions. It's perfectly possible for there to be no real solution. If the curve lay up here, I'd have no solution. There's no value of x that makes y 0. And so then we're looking at complex numbers, imaginary numbers, to try and carry on with this, if you remember. But what you're going to be looking at, certainly for this assignment, is values, real solutions to quadratic equations like this. How do we go about solving x squared minus 6 equals 0? We could solve it by plotting it and then zooming in on those values, but how do we actually solve it? Sorry? Square root of 6. Okay, so in other words, add 6 to both sides, square root both sides. Yeah. And if we put that into a calculator, what do we get? X equals 2.5, you say, Tyler? 2.45 to 3 significant figures, say. So now we're going to have to start thinking about rounding when we put the answer down. And what else have we got to remember to do? I left a small gap between the equals and the 2.45. Plus or minus, Tom, yeah. The answer could be positive or negative. Don't forget that. There's always two solutions. And if we look at the sketch, we can see plus or minus. There's two solutions, plus 2.45 or minus 2.45. We can see them there. Okay. Note that in this particular quadratic equation, which is very easy to solve, x squared minus 6 equals 0, it's symmetrical about the y-axis. So whenever I get a quadratic equation like this to solve, where there's no x term in it, so this is an example of where there's no term involving x, then it's always symmetrical about the y-axis. So the solutions are going to be the same, but one is going to be positive and one is going to be negative. And the reason is, whenever I come to solve it, when I come to here, then I'm always going to be adding whatever this number is to both sides. I'm going to get x squared equals a number, so the answer would just be the root of that number, which will be positive or negative. Okay? Worth bearing in mind that that's what you're going to expect to get if I've got a formula like this, or an equation like this rather, to solve. How about something like that? Now we have an x term in there, but there's no number, no constant. If we look back at this previous one, there's something more we can get from this sketch. X squared equals minus 6. Anything particular about this curve that might allow us to tell that? Tom? Yeah, it crosses at negative 6. When x equals 0, look back at the equation. When x equals 0, minus 6 is the solution. So y equals minus 6 when x equals 0. The constant, in other words, tells me where it cuts the y-axis. So if there is no constant term, where does it cut the y-axis? Pardon? Yeah, but where else? Where does it cut the y-axis? Not the x-axis, Tom, the y-axis. At 0. Okay? Which is always going to be the case because there's no constant. So if there's no constant in a quadratic equation, one of the solutions, remember there's always two, one of the solutions is going to be 0. Okay? So we're just looking for the other one. So x squared minus 6x equals 0. The first step is crucial in solving equations like this. Because there's no constant, we've got a term involving x squared and a term involving x then. Both of those terms have x in it, so what can we do? Waiting for the magic word. Begins in F. Factorize. What can we take outside a bracket that's common to both of these terms? Yeah. X. What am I left with inside? Right. And that's always the first term when I've got a quadratic equation to solve where there's no constant. Because there's no constant, x appears in both terms, so I can factorize. And that means, and this next step only works if the right-hand side is 0, so you remember how important the right-hand side being 0 is in these things. Because the right-hand side is 0, we can now say either I've got to make the left-hand side 0, remember, so it balances the right-hand side. Either x equals 0, because if x equals 0, the x outside the bracket here, 0, it doesn't matter what's inside the bracket, the answer is going to be 0. So one solution is x equals 0. And that agrees with what we were saying a minute or two ago. One of the solutions is always 0. So either x equals 0 or the bracket 0. And that means what value of x? Right. We'll allow the bracket to 0, x equals 6. So, yeah, you could substitute this 6 back into the original equation and check you get 0. Right, Tyler? Yeah. And if we look at the thing, we can see it cuts at 6. Okay? So if you've got a quadratic equation with no x term in it, it's easy to solve. If you've got a quadratic equation with no constant in it, it's easy to solve. If we've got one with an x term in it and a constant, then we have to either factorize, remember that little thing we played around with, perfect square method is another one we can play with. But based on the perfect square method, we would use the quadratic formula. So if I want to solve something like this, look at the curve. The constant term, remember what we were saying earlier, it tells us where it cuts the y-axis. So when x equals 0, y equals minus 6. So this point here is minus 6, where it cuts the y-axis. And then we've got two places where it cuts the x-axis. Two solutions, but now we've got to do a bit more work to get them. And unless you can see a very quick way to factorize these things, generally we fall back on this quadratic formula, which is the solution to the general quadratic. And so, in other words, a is the number in front of the x squared term, b is the number in front of the x term, c is the constant. And then we just plug those numbers into the equation. So I'll just pause this video for a sec while you do that and work out what x is, please. Just a quick note then on this sense. So the quick solution, list what these things are, a, b and c. Be careful of the negatives when you're putting them in, minus or minus. I wouldn't put the negative sign in the calculator because that will always lead to odd results. If I put negative 6 squared in the calculator, it gives the wrong answer. So just ignore the negative sign. Minus a minus again is going to give us a plus, so just got to be careful of the signs when we do this thing. And then when we do it, we get answer x equals negative 0.87 or 6.87. And if you look back at the sketch, we'll see that that pretty well agrees. It cuts at negative 0.87 or 6.87.